It is not permissible to tap a number 12 wire to an existing number 6 wire to supply a small breaker for an outlet. The ampacity of the number 6 wire is significantly greater than the ampacity of the number 12 wire, which could result in an unsafe condition. The National Electrical Code, or NEC, mandates that the ampacity of a conductor must be sufficient to carry the intended load, and that the conductor must be adequately protected by a circuit breaker or fuse of the appropriate size. In this specific scenario, the number 12 wire would be inadequate to safely carry the load of the outlet, and the number 6 wire will not be appropriately protected by the small breaker intended for the outlet circuit. If there is a need to add an outlet to the 8-track disconnect, the correct and safest approach is to install a completely new circuit directly from the electrical panel. This measure ensures that the newly installed outlet is properly protected by its own dedicated circuit breaker of the correct amperage, and that the ampacity of the wiring used is sufficient to handle the electrical load that the outlet is expected to bear. Attempting to tap into an existing circuit with a smaller gauge wire can create several potential hazards. Firstly, the smaller gauge wire, in this case number 12, is not designed to handle the same amount of current as the larger gauge wire, number 6. Overloading the number 12 wire can cause it to overheat, potentially leading to a fire. Secondly, the existing circuit breaker protecting the number 6 wire is sized to protect that wire based on its ampacity. It will not provide adequate protection for the smaller gauge number 12 wire, meaning that a fault in the outlet or the wiring connected to it could go undetected long enough to cause damage or a fire. Thirdly, tapping into an existing circuit without proper planning and consideration for the overall load can lead to voltage drops, which can affect the performance of the equipment connected to the circuit and potentially damage sensitive electronic devices. The NEC provides detailed guidelines and tables for determining the appropriate wire gauge and circuit breaker size for various electrical loads. It is essential to consult these resources and follow the recommendations to ensure the safety and reliability of the electrical system. Moreover, it is always recommended to consult with a qualified electrician when making changes to an electrical system. A licensed electrician has the knowledge, skills, and experience to properly assess the situation, determine the appropriate solutions, and perform the work safely and in compliance with all applicable codes and regulations. Attempting to perform electrical work without the necessary expertise can be dangerous and can potentially lead to serious injury or property damage. In addition to the safety concerns, tapping into an existing circuit with a smaller gauge wire may also violate local electrical codes and regulations. Many jurisdictions require that all electrical work be performed by licensed electricians and that all installations meet specific standards. Failure to comply with these requirements can result in fines, penalties, and the need to redo the work at additional expense. Therefore, to reiterate, the safest and most code-compliant approach is to install a new, dedicated circuit from the electrical panel for the new outlet. This will ensure that the outlet is properly protected, that the wiring is of adequate size, and that the electrical system as a whole remains safe and reliable. When installing a new circuit, several factors need to be taken into consideration. Firstly, the total load that the outlet is expected to handle needs to be determined. This will dictate the required amperage of the circuit and the appropriate wire gauge. Secondly, the length of the wire run from the panel to the outlet needs to be considered. Longer wire runs can result in voltage drops, which may require the use of a larger gauge wire to compensate. Thirdly, the type of outlet being installed needs to be taken into account. Some outlets, such as those used for appliances or heavy-duty equipment, may require a dedicated circuit with a higher amperage rating. Fourthly, the location of the outlet needs to be considered. Outlets installed in wet or damp locations, such as bathrooms or kitchens, may require special ground fault circuit interrupter, or GFCI, protection to prevent electric shock. Once these factors have been carefully considered, the appropriate circuit breaker size and wire gauge can be determined. The NEC provides tables that specify the allowable ampacity of various wire gauges based on the type of insulation and the installation conditions. It is essential to consult these tables to ensure that the selected wire gauge is adequate for the intended load. The circuit breaker should be sized to protect the wire from overcurrent. The NEC specifies the maximum allowable overcurrent protection for various wire gauges. It is important to select a circuit breaker that is no larger than the maximum allowed for the wire being used. Once the circuit breaker and wire gauge have been selected, the wiring can be installed. The wiring should be installed in accordance with all applicable codes and regulations. This includes using the proper wiring methods, such as conduit or cable, and ensuring that all connections are made properly and securely. The outlet should be installed in a suitable electrical box and properly grounded. Grounding is an essential safety measure that helps to protect against electric shock. After the wiring and outlet have been installed, the circuit should be tested to ensure that it is working properly. This includes checking the voltage at the outlet and verifying that the ground fault circuit interrupter, or GFCI, protection is functioning correctly. Finally, it is important to label the circuit breaker in the electrical panel so that it can be easily identified in the future. This will help to prevent accidental disconnection of the circuit and will make it easier to troubleshoot any problems that may arise. In summary, tapping into an existing circuit with a smaller gauge wire is generally not recommended and can be dangerous. The safest and most code-compliant approach is to install a new, dedicated circuit from the electrical panel for the new outlet. This will ensure that the outlet is properly protected, that the wiring is of adequate size, and that the electrical system as a whole remains safe and reliable. Remember to always consult with a qualified electrician when making changes to an electrical system. Here's a breakdown of why the original approach is problematic. Firstly, ampacity mismatch. The number 6 wire has a much higher ampacity than the number 12 wire. Ampacity refers to the maximum amount of electrical current a conductor can carry continuously without exceeding its temperature rating. Tapping into the number 6 wire with a number 12 wire creates a situation where the smaller wire is potentially subjected to a current exceeding its capacity. Secondly, overcurrent protection circuit breakers are designed to protect wires from overcurrents, which can cause overheating and fires. The circuit breaker protecting the number 6 wire is sized based on the ampacity of that wire. It will not provide adequate protection for the number 12 wire. If an overcurrent occurs on the portion of the circuit served by the number 12 wire, that wire could overheat before the breaker trips. Thirdly, NEC compliance. The NEC sets standards for safe electrical installations. Tapping into a larger wire with a smaller wire without proper overcurrent protection for the smaller wire violates these standards. Fourthly, potential hazards. This configuration creates several potential hazards, including fire, electrical shock, and equipment damage. Overheated wires can ignite surrounding materials, leading to a fire. Inadequate overcurrent protection can expose individuals to the risk of electrical shock. Voltage drops caused by the undersized wire can damage sensitive electronic equipment. Here's a step-by-step approach to adding a new outlet safely and in accordance with the NEC. Firstly, determine the load. Calculate the total load that the new outlet will serve. This includes the amperage of any appliances or devices that will be plugged into the outlet. Secondly, select the appropriate wire gauge. Consult the NEC tables to determine the appropriate wire gauge based on the calculated load and the length of the wire run. Consider factors such as the insulation type and the ambient temperature. Thirdly, choose the correct circuit breaker size. Select a circuit breaker that is sized to protect the wire from overcurrent. The NEC specifies the maximum allowable overcurrent protection for various wire gauges. Fourthly, install a new circuit. Run a new circuit from the electrical panel to the location of the new outlet. Use the selected wire gauge and install the wire in accordance with all applicable codes and regulations. Fifthly, install the outlet. Install the outlet in a suitable electrical box and properly ground it. Sixthly, test the circuit. Test the circuit to ensure that it is working properly. Check the voltage at the outlet and verify that any ground fault circuit interrupter, or GFCI, protection is functioning correctly. Seventhly, label the circuit breaker. Label the circuit breaker in the electrical panel so that it can be easily identified in the future. Additional considerations to keep in mind are GFCI protection outlets installed in certain locations such as bathrooms, kitchens, and outdoor areas require GFCI protection. GFCI outlets are designed to detect ground faults and quickly disconnect the power to prevent electrical shock. Arc fault circuit interrupter, RFSI, protection of SIs are designed to protect against arc faults, which are a common cause of electrical fires. Some jurisdictions require RFSI protection for certain circuits. Local codes and permits always check with your local building department to determine the applicable codes and permit requirements for electrical work. Inspections schedule an inspection with the local building department to ensure that the electrical work is performed in accordance with the codes. Hiring a qualified electrician electrical work can be dangerous. If you are not comfortable performing the work yourself, hire a qualified electrician to do it for you. The National Electrical Code Article 240.4 addresses the protection of conductors. This section of the code provides specific requirements for overcurrent protection of conductors based on their ampacity. It generally states that conductors must be protected against overcurrent in accordance with their ampacities as specified in other articles of the code. The overcurrent protection device, such as a circuit breaker or fuse, must be sized to protect the conductor from overheating and potential damage due to excessive current flow. There are some exceptions to this general rule, such as when the conductor is part of a motor circuit or when specific conditions allow for the use of a larger overcurrent protection device. However, in most cases, the overcurrent protection device should not exceed the ampacity of the conductor it is protecting. Article 310.15 provides guidelines for determining the ampacity of conductors. This article includes tables that list the allowable ampacities of various types of conductors based on their size, insulation type, and installation conditions. These tables take into account factors such as the ambient temperature, the number of conductors in a raceway or cable, and the presence of other heat-generating equipment. When determining the ampacity of a conductor, it is important to consider all of these factors to ensure that the conductor is not overloaded.